Well, now it's time to set up the quantities of each component following the given circuit. Okay, what I'm trying to say is the resistance must be set up following the values provided in the original circuit. Editing a component is extremely simple. The inside the schematic editor, editing any component is just double click on the component and automatically a window will appear that will allow the configuration. It's extremely simple and you can do it, okay? What we will do now is, for instance, we will set up the resistor R1 to 5 ohms. What you need to do is double click here at the resistor and you will get here the dialog and we will include 5 ohms. Then we press OK and the value is stored in the resistor R1. Then we will go to the resistor R2. Extremely simple. We are planning to edit the value. And what we need to do is double click on the resistor R2. And that resistor must be 10 ohm resistant. Okay. Similar to resistor R3 here at the top right. And double click and this resistor is 6 ohms and we include 6 ohm resistance for resistor R3. Finally, the last passive component, and here we have the resistor R4. Double click and the dialog we put a 4 ohms resistance over there and then press OK. Now we have finished with all the passive component times for the active components. In this circuit, we have two voltage source and voltage source V2 is located at the middle here in this branch. Double click and we will keep this voltage as constant voltage because this is a DC voltage source, ideal voltage source, and we need to keep the configuration as constant, okay? But the voltage magnitude must be defined. In this case, the voltage is 10 volts, and then we press OK. We move to the voltage source number 2. In this case, number 1. Double click on it, and we keep the source as a constant source with a voltage of 15 volts as depicted here at the circuit. At this moment, we finish the editing all the components, okay? At this moment, we have all the data in our system. However, there is something very important. If we use this system, we will not be able to capture any numerical results. And the reason is that inside the schematic editor, we have electric components and they can work together, but they are not allowing transmitting the signal between the schematic editor and the HIL SCADA. For that reason, we need to install measurements. Anytime that you need to collect measurements in your model, you need to use the appropriate measurement. In this case, we are interested on currents, and for that reason, we will use current measurement components. Current measurement components, they are located at the library inside the folder measurements. And the first option over there, you will find the component, the name is current elements. What you need to do is very simple, use the drag and drop, and you will place those current measurements and rotate accordingly in order to replicate the same structure that we have in the original circuit, okay? Well, but right now we have three current measurements, but those current measurements, you must remember, current measurement must be installed in series connection. For that reason, I need to make few changes at the schematic diagram that I already finished, because right now I need to do something very important. Those measurement devices at the moment, they will be able to collect the signal, but I need to send that signal to the HIL SCADA. To do that, I need to enable signal processing in those current measurements. And to enable the signal processing is extremely simple. What we need to do is double click at one of these current measurements, and a menu like this will open. And there is one tab for general data, but the important one for me is signal processing. Signal processing, there is a flag that by default is false, but I will change to true. If I change this signal output to true, what will happen is that the icon for the current measurement will change. And right now you can see a third terminal in blue color. In this case, the green terminals over there, they are inside the electrical component environment, but this blue terminal, the blue color, means that this is a signal that can be used for signal process. Well, right now we have three measurement devices, and all of them are enabled to send the signal to the SCADA. But wait a moment. They are not sending the signal at the moment. We need to do one more step before that, okay? Okay, we have the three current measurements. Now we need to connect in series at the three different locations. And that is the next step. The next step is I will cut this connector and I will place the current measurements and use the basic principle that I teach you before. Connecting those terminals, click here, click there, and we will connect these current measurements in series with this voltage source. Then we will click here on the other terminal of this current measurement and click at the resistor, and we will close this loop over here. Your job is to do the same for the second and the third current measurement. When you do so, what will happen is that right now you will have three current measurements installed at the three different branches in series connection, and we have terminals, we have a port that is able to provide signal for signal processing. Okay? Well, now there is a very critical process. At this stage over here, as the system is shown at the left-hand side, we are here finishing inside the schematic editor. The schematic editor, we create the electrical domain devices, voltage sources, resistors, measurement devices, those current sources over there. But then we need to send the signals of our model from the model to the SCADA. And to do that, we need signal processing devices. And that is where one very important device is coming to help us. Inside the library, there is a component called SCADA output. The SCADA output is basically the component that allows taking the signal from here and sending to the HIL SCADA. And then when that current signal arrives to the HIL SCADA, we have the possibility of using for several purposes. One of them, in this very basic example, is presenting to you the numerical value of that current. And that is what we will do now. What we will do now is basically we will install in our schematic diagram the SCADA output. The SCADA output is located here inside the library. If you go inside the folder called Signal Processing, then there is a subfolder called Sinks, and inside you will find the SCADA output. Then you drag and drop, and you will find your SCADA output in your schematic diagram. Final step is connecting the current measurement to the SCADA output, and now we have the current I1 moving from the electric world, electric environment into the signal environment that can be used at the SCADA environment. Okay? Now your job is to put SCADA 2 for the current I2 and a SCADA output 3 for the current I3, okay? When you finish that process, well, we are finishing almost at the schematic editor. At this stage, like here, the circuit is ready to be compiled. And the next step that we will do right now is we are planning to compile the schematic, and hopefully everything should be fine, okay? To compile the schematic, there are two different ways. One is compile the schematic, and this is basically to test if your model is properly compiled. And there is a second option that is compile the model and then open the HIL SCADA. Okay? At this moment, I will run just compile the schematic and see if the model is properly working. Okay? To run the compile schematic or the compile schematic and open, there are two icons over here. You will identify those icons at the toolbar, or there are another option that is going to the menu and going model, and you will find here the compile schematic icon. And the third option is just press F5, and when you press F5, the schematic editor will compile the model. Okay? Well, if you use the icons at the toolbar or the menu or just the keyboard, I want you to compile the schematic. And this compilation will take few seconds, but the very important steps will appear at the message window. The message console is below the working area. In this case, I increased the size in order to show you all the steps running during the compilation process. In this compilation, you will see that there are blue and green text. I just focus today on the green, and in this case, the first check and the validation pass is related with the components type. And then there are a second validation related with compiling the electrical parts. And finally, here there is an information indicating that the compilation process finished and it was successful. Okay? At this moment, with those messages, we are sure that the model is properly created, properly set up, and is ready for simulations. Okay? As you can see over here in the message console, there are few There are several lines, to be honest. There are several lines indicating different options and different percentages and so on. To be honest, that information is extremely important, but in this case, we are running a very basic model, and that information is not critical. The critical one for this basic model and for your first example is that you get the model properly compiled. And as I can see over here at the very end, the model is ready for simulation, and congratulations, you compiled your model.